An easier solution might be to write a function called str join 3 that takes these 3 directly, but this doesn't scale. You can, now if you want to join 4 or 5 or 6 or 7, you have to write a single function for all of these. You might maybe want to write a macro if you are experienced that does this, but in the end, you're still building on the blocks that C provides you with, and then you're trying to crumble down the problem into what C provides you with. So basically, C provides you with functions, and what you're going to do is you're going to write a function for each and every single combination that your problem has. If you have 10 strings, you need a function that takes 10. If you have 100, well, maybe you want to use a list, and this is where objects come in. If you have maybe 40 different strings, or 42, let's do it like this, and you want to join all of these strings together, the general problem that you have is, if you're trying to join these strings, you need some kind of algorithm that deals with n objects. If you have n objects inside of here, you basically need an algorithm that doesn't take 1 or 2 or 3 or 4, but n. And having this memory management issue here, where you have to write your code very explicitly to get rid of this pointer, basically means that this one doesn't really scale well. Now, this is where objects come in. Again, this one is already some kind of object that is solving the problem of, well, having 1, 2, or 3 objects in a row. Lists do that for you. Now we can build on top of that. So instead of cramming the problem down into the C language, let's allow the C language to extend itself. So we build bigger and bigger shells around the C core language until we have some kind of a feature in which we can also build our problem. This sounds very abstract, but what I mean is, instead of trying to package this problem into something that C has, we are building something on top of C with new ideas until we come to this. For example, when you do file operations, you already have file descriptors. File descriptors are a pretty good example of very crude and rough objects, but in the end, they are exactly what I'm aiming towards. Now I'm going to add our list of objects that we already know, something new, the file descriptor. Does anybody remember what a file descriptor is? So how you use it?
I don't know what file descriptor is.
That's good, because it's hidden from you. When you use a file descriptor, you just say int fd for your file descriptor, and then you call the, I don't know, the open function, for example. Or maybe you use the read function, put the file descriptor in, and then some other arguments, and then you get something out. Again, what you have here is just an integer. You don't care what data this integer is associated with in the operating system that handles these calls. But you just give the operating system the integer that was being returned from here, you give it just back, and the operating system will know what file you meant. Because somewhere inside of the operating system, there is some kind of mapping between the file descriptor, let's say 0 and 1, which go to the std in and std out. Or maybe you have the file descriptor 25, which points to the actual file on disk, which is somewhere in the root directory, I don't know. So the operating system will have an internal mapping of the file descriptor number and some kind of data. But our user level program only sees this part. We don't see the data that the operating system uses inside of here. We don't see the data that the operating system uses. We only see the integer. But that's enough for us to talk about or have this file descriptor which represents a means of reading or writing, opening and closing. Again, what we are doing is we are taking C's int that's inside of here, and we are building a ring around that with file descriptors that didn't exist in the C language itself, but we used the integers to build something more powerful out of that. So we don't have to talk about the files here directly, we just tell the operating system to open this file once. It could also be a pipe or a network socket or something completely different. Standard input, standard output. We don't care. We have a number now. We give that to read, and read will know what to do based on what number we give. If we give it a different number, read might behave completely differently. If we give it the number of a file, it's going to read from that file. If we're going to give it, let's say, the standard input file descriptor, it's going to wait until the user types something. It's not going to go to the disk. It's going to go to, I don't know, to the terminal and read some data. And so the behavior of the read function totally depends on this object. And again, the most important part of objects is what's called encapsulation. I'm actually going to write that down because that's important. And this is exactly what this gap here does. This gap, well, we only know this part, and this part is hidden. The fact that these two are separate and hidden is called encapsulation. There we go. And you can do stuff like that in languages like C++ pretty well. But as you can see here, the C language also has the same feature. It works a bit differently, but you can still build on top of that. And I mean, you might still be asking, so we have integers, we have char pointers for strings, why do we even need more objects? I was already hinting at that with the strjoin. What I'm now going to do is I'm going to give you very concrete objects that you might want to use later on in your 42 projects here. So I'm going to talk a bit about different kind of objects that you might want to use, how to write them in the C language, and I think you're the ones who are going to decide on whether or how to use that in your code. So I'm only going to give you a few cooking recipes, so to speak. Okay, where did I leave the other pen? I don't know. Looking for the blue.
In your pocket somewhere?
Nope. I think it's right at the bottom. I have to be careful where I go. Okay, so let's clear that off. Can I clear this off for you? Okay. I mean, if not, you have the recording, hopefully, if nothing goes wrong. Because that happened already. Thanks to the camera team. Okay. Do you have any questions so far about objects? Or should I just continue with one? Because in my opinion, it's often better if people ask questions right away.
So what's specifically the definition of an object?
The definition of an object, oh, that's quite difficult. Like, there are many, even computer science professors who don't agree on that. I think I might even be going to give a talk about that, like another lecture, because it's pretty hard to explain. Technically speaking, an object is air. It's nothing at all. It's just a concept in your head. This might be a bit mathematical now, but don't be too afraid. Let's say you wanted to have a pair of numbers, two numbers joined together, that you can treat as one. For example, like some kind of xy position in your space. An xy position is always two numbers, the x coordinate and the y coordinate. And you want to tie them together into one object, which represents a point. You would do that in C by writing a struct with the x coordinate and the y coordinate being a point. So this is already hinting to the second part of the lecture here. But technically speaking, if you have a point, so let's say you have a function called, not p, I'm going to call this function make point. Okay? This is roughly our equivalent to the open function that opens a file descriptor. Like, you have no file descriptor, you call the open function, and suddenly you have a file descriptor. This is what people call the constructor function. This is a technical term that you might have to remember because it's important in C++. This is called the constructor function. And as you can tell by its name, it's going to construct an object, a new one. So you give it the data that it needs, for example, for the open call, when you want to create a new file descriptor, you give it the path of the file and the read and write permissions, and then you get back the file descriptor. If you have a point, what would you have to give to that point? Well, the x and y coordinate that you want to put into it. So it takes, let's say, a float. You all know about floats, right? Floating point numbers. It's like an integer just with decimal points. Integers are like 42, and floats are 42.3. That's why it's called a floating point number. Float for short. So we say float x, float y, and that's the function. Like, basically that's what the function looks like. And if we want to make a point, we just say p, the type of that point. I'm going to leave that open at the moment, because I'm going to show you that this data doesn't really matter here. But we can now say make point of x and y. So we can say, for example, 42.3 and minus 5. And this will create a point, put it into p, and now you can carry p around just like you can carry around file descriptors. So for example, you can tell to the system, okay, I want to get the x coordinate with that. Again, for example, when you want to write to a file descriptor or read from it, you call a function and pass the file descriptor as the first argument. It works similar to that. If you want to get the x coordinate of a point, you just say point get x, and then you pass in the point, and it's going to return the x value, which is going to be the result of that. So again, you pass in this p that you just got, you don't care what it is, you just pass it in, and now you get out the x. Same applies for the y, of course. Is that clear to you? It might be a bit abstract, so you might be wondering, why would I ever need this? Or why is that useful? Why shouldn't I, for example, the more experienced people will just ask, well, why can't I just write